I don't even know why this is a question sometimes, but lots of teachers will ask you to draw all the isomers of C6H14. The first thing I'm going to do is just lay out a 6-carbon chain. 6 carbons, that's the C6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hydrogens. This is the first isomer of C6H14. Now we need to be able to create other isomers here. We need to be able to break this chain and reattach it in some way that it's still 6 carbons, and we still have 14 hydrogens, but it's not arranged in quite this way. The way that I like to do that is step by step. What's the shortest chain that I could cut off of here? Well, that's having 1 carbon. So let's cut that 1 carbon off. I now have a 5-carbon chain, but I have to reattach it somewhere. I can't reattach it to this carbon because it was already on that carbon and then it's the exact same molecule. I can't reattach it to this carbon because then I've just created another 6-carbon chain, and that's exactly what I had before as well. One of the isomers has the carbon sticking out here. And notice the number of hydrogens: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's still C6H14. But I could have also jammed that carbon onto the middle of the 5. This is also distinct from the others in that this is a 6-carbon chain, this is a 5-carbon chain with 1 sticking out of the 2nd carbon, this is a 5-carbon chain with 1 sticking out of the 3rd carbon. 3 hydrogens, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Beautiful. So that's what we can do with a single carbon that we chopped off the end. What if we chopped 2 carbons off the end? We end up with a 4-carbon chain, and we need to create, or we need to reattach those 2 carbons somewhere along here. Well, the first way that I can see is to attach 1 here and 1 here. The longest chain here is still 4 long, but I have 2 methyl groups sticking out of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Beautiful. Oh, I didn't attach it there like I should have. One other place we could try to attach this is maybe attaching it to one of the middle carbons. Again, we can't attach it to the end carbon because then we're just right back where we started here. But the issue here is you have 1, 2, 3, 4, 5 carbon chains with 1 sticking out of the middle. This is exactly the same as this, so that's not unique. Honestly, I can't think of any other isomers beyond splitting the 2 apart and attaching them to the middle. Because again, if one of them gets attached to the end, I now have a 5-carbon chain, and we've already taken care of all the 5-carbon chains. The last thing is maybe we could cut off 3. I don't know if this is going to work. Oh, hello. I botched that. There's another way to attach these together. You could have a 4-carbon chain and put both of those ones that you chopped off the end onto the same carbon. I would have been remiss to ignore that one. Again, the longest carbon chain you'll find here is 4 long, and the 2 carbons are attached to the same single one in the center. Alright, last chance here. Let's see what we can do with a 3-carbon chain. What could I do to add 3 carbons to this that's going to allow me to say that that molecule is different from all the others? I can't just attach them here as a chain of 3 because then I have a chain of 5 and I already took care of all the 5s. I can't put 1 here, 1 here, 1 here because then I have a chain of 4 and I already took care of those. I don't think I can do anything with that. I think these are the only isomers of C6H4. Let's name them while we're here. This is just called N-hexane. It's 6 long. Actually, most people just call it hexane. I call it N because it's just normal. There are 2 names for it. This is a pentane because it's 5 carbons long, but there's a methyl group sticking out of the 2nd carbon. which means it's 2-methylpentane. Similarly, this is a pentane, but it has a methyl sticking out of the third one. That's 3-methylpentane. This, the longest chain I can find, is a butane. It's 4 long. And I have methyls sticking out of the second and third carbons, which makes it a 2,3-dimethylbutane. All one word. And this one, similarly, is a 2,2-dimethylbutane. I challenge you to find a propane that has the formula C6H14. But who knows? If you can find another isomer, post it in the comments, but I'm Chemist Nate, and I'm pretty sure this is it. Hey, best of luck to you.
Hey everyone, now before watching this video, you should have seen a video called isomers. Okay, now what is isomerism? We know that isomerism exists when you have two or more structures which exist that have the same molecular formula but different structural formula. So what does that mean? Okay, so if we look at this example here on the right hand side, we see that we have two isomers of butane. They both have the same molecular formula, which is C4H10. However, the way that they are structured is different. Hence, they are called isomers. Okay, so we can recall that isomers have the same what? What is the same and what is different? Okay, now if you would have said that the molecular formula is the same but the structural formula is different, then you are correct. Okay, so isomers. So we have a question where you ask to draw two isomers of butane. So how would we go about doing that? So here we have our two isomers of butane. Now it is important to know that you should always start off by writing your straight chain, which is the one that we would have practiced last class. Okay, so this is your straight chain, and now only thing that we're going to do is we're going to take the end, we're going to break the end, and then we're going to attach it somewhere in the middle. So here you see the end, which is this right here. We took it out and then we attached it right in the middle, and hence we have an isomer of butane. That's it. So now you're asked to draw the isomer for heptane. Okay, you are asked to draw the isomer for heptane. So now we know that the formula for heptane is C7H16. And it is important to note that when you're drawing isomers, the first one you should draw is the straight chain, which is the regular one that we would have drawn in class. Everything with your carbon, you just have your carbons and then you have your hydrogen, and everything is literally on a straight line. That's the straight chain alkane. Okay? So after drawing your straight chain alkane, now we need to draw an isomer of heptane. Okay, so we need to draw, another isomer of heptane because we already have one. This is actually one, okay? The easiest one that you should always get. Now, what we're going to do is we're going to just break off the end. Okay, we can break off the end, and remember, once you break off the end, you could put it anywhere in the middle, and that's going to be considered another isomer because the structure is going to be different. Okay, now keep in mind that if you break this end here, you cannot put it on the next end because it's still going to be a straight chain. So hence, this is why we have to take the end, break it off, and put it somewhere in the middle. Okay, so this is us right here, and we have broken this end, and now we're going to put it in the middle. How do we go about doing that? The first thing you should do is you should draw the first thing you should do, of course, is you should draw everything back just as it is. Okay, draw everything back just as it is. Draw everything back just as it is, and then you're going to take this end here, and you're going to just attach it in the middle. Okay, and when you're done, make sure you check over and make sure that your molecular formula is still C7H16. So here you have 1, 2, 3, 4, 5, 6, 7 carbon atoms, and then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then you have 3 carbons here. So altogether you have 16. Okay, so this is an abbreviation that I would have done, but you can just, like we did with the other example, you could just write out, you could just show your carbon. You could just show this as it is with the carbon and then your hydrogens, your 3 hydrogens attached to the carbon. That is also fine. Okay, so now we have yet another isomer, okay, of the same C7H16. Okay, so of course we have our OG, which is our heptane, right? So we're going to draw another isomer of C7H16. So of course, our first one, of course, is our straight chain, which is our heptane. And now we are going to go ahead and, again, same process, we're going to be moving the ends. Okay, so now I'm going to move 2 ends because I can do that. I can move as much ends as I want. Okay, but when you're moving the end, just make sure that your straight chain, is still longer than the ends that you're moving. Okay, make sure that your straight chain is longer than the ends that you're moving. Okay, because your straight chain is going to be called your parent chain. It has to be the longest. It has to be the longest chain, and then you can have the little ends attached to it. So now, instead of taking just one end, I'm going to take 2 ends. So I'm going to take this end here, and I'm going to take this end here. I'm going to cut that out, and then I'm going to paste it somewhere in the middle. So I can paste it anywhere I want, but I decided to put it right here. Attach it as carbon atom. I attached both of them to the same carbon atoms. I didn't have to do that. I could have attached one to this, and then I could have attached the other one to the other CH3 to this right here, to this carbon right here, but I decided to put both of them on the same one. And I can do that. Okay, once the carbon atom is in the middle, I can attach a group to it. However, if it's on the end, I can't attach it. So I can't attach it to this, but I can attach it to this, or to this. Okay, and that's it. I have another isomer. Okay, so now I am going to draw yet another isomer. Okay, C7H16. Of course, we have again our original isomer, which is our straight chain heptane. Okay, and now I am going to go ahead and I am going to break apart this chain so that I can create a different structure for C7H16, because that's all I'm doing. Okay, so now what I'm doing is I'm going to take out this end here and I'm going to attach it here, and then I'm also going to take this end here, but instead of just taking 1 carbon atoms, I'm going to take 2 carbon atoms. Okay, I'm switching it up. Okay, so I can take 2 carbon atoms. Okay, remember I can remove carbon atoms, but I just need to make sure that the straight chain is longer than what I have attached. So right here I have 1, 2, I just have 3 things attached to it. So that's fine. Okay, once this straight chain is your longest chain, you're good. Okay, so now I'm deciding to attach both of these carbon atoms with the hydrogens. Okay, so see, you could do it either this way by just writing it over as it is, the carbons and the hydrogens, 2 carbons with the hydrogens, or you can actually just summarize it by just putting in the carbon and then the number of carbon atoms and then the number of hydrogens, like what I did here. So right here you would have CH3 because you have 1 carbon and 3 hydrogens, whereas up here, if I wanted to do the same kind of formula here, all I had to do was just add up the carbons. So it'd be C2 and then add up the hydrogen, and then however much hydrogens I have 1, 2, 3, 4 hydrogens. Okay, so that's pretty much it. That's it. So now you have another isomer of C7H16. That's it.